Welcome to an awesome algebra session on factoring by grouping. This question says to factor the following by grouping: 6m minus 35p minus 5mp plus 42. So first thing I like to do is see, hey, can I factor anything out of something out of everything? Well, here's an m. Oh, that term doesn't have an m, so it won't work. Here's a 6. That term, that's made up of 7 times 5. Okay, so just looking at the first two terms alone, I see there is no GCF from all of them. And the fact that the first two have nothing in common, and look, this last two, they also have nothing in common. So what I'm going to do then is I'm going to rearrange the problem. I'm going to just switch these two around. Okay, 6m minus 5mp minus 35p plus 42. So I just switched these two around. Okay. So now I could factor the first two and the last two. But I want to point out that this term has the p in the first place, and this one has it in the, so it's in the second term of these two. See how it's the second term of these two? And the p is in the first term of the second two. Let's just switch these two again. So let's just change the order one more time. So that way I've got my p's in the second term of both. It'll make it just a little bit easier to factor. Okay, this is a positive 42, so I'm going to put plus 42. And that's a negative 35p, so minus 35p. Okay, now let's look back at it one more time. So I got the first two and the last two. The first two, I have 6m minus 5mp. See, the p is my second term here, plus 42 minus 35p. The p is in the second term on this one. Way easier to factor. So, the first piece, what can I factor out? M. M is in both pieces. What's left inside? 6 minus 5p. Plus, if this were a negative, I'd factor out the negative, but it's a positive, so I'm going to leave it. Okay, now I have to figure out 42 and 35. What do they both have in common? What can I factor out of both? Well, 7. 7 will be factored out of both pieces. So 6 times 7 is 42, minus 6 times 5 is 35, and then I also need the p. Oh, perfect. Okay, now this really, really hard problem is so much easier because I've got a 6 minus 5p and a 6 minus 5p there. If you say didn't do this second set of factoring, this might have been turned the opposite direction, and you might have to have factored out a negative or change the order around or do something different because of that. So you just want to be careful. And we're ready to factor one more time. 6 minus 5p parenthesis times m plus 7. Okay, completely factored. Okay, completely factored. So here's my tips. 1. GCF. Is there a GCF? Is there anything in common with all of them? Yes, no. Super helpful. 2. Check out the order. Okay, group things alike. So these both have m's in them. These both just have numbers. There's a p in one and not the other, but they both have numbers that have a common GCF. So I want to make my order so that way I get GCF pairs. So I have a greatest common factor that is not 1 and both sets of groups. So this pair will have something in common and this pair will have something in common. Okay. With the order, you might be concerned about like having similar variables next to each other. So similar variables. Similar variables. Sometimes it's helpful to look at the exponents and put like similar exponents together. So you might just check out the exponents with that. And you might also look for is there any common factors? So anything that's common with any of the factors. So in the second set, notice both were divisible by 7. So I wanted to check that out. All right, you ready for a problem on your own? Go ahead and try out the problem. Put your solution in the comments. If you have a question that you would like to see answered, go ahead and add that to the comments as well, and it might be featured in an upcoming video. Good luck!